Very good morning, dear students, friends. Now we are going to see about the shear force and bending moment for a double overhanging beam in which the two support A and B is having a distance of 1 meter from the left support and from the right support. For example, I am taking this as a beam, this pen, right here the right hand support and here left hand support, right? So this is of 1 meter and this portion, overhanging portion is 1 meter, and in between the supports A and B is 3 meter, and this overhanging portion is 1 meter and this overhanging portion is 1 meter. So in this beam a load of UDL. So UDL is loaded on the beam for the entire span of 5 meter of double overhanging beam of 10 kilonewton per meter run over the entire span. Right, the load is applied on a beam downward load of 10 kilonewton per meter and over the entire span. What will be the reaction at support A and support B? And this portion left end I call it as C and the right end overhanging is D. So A, B, C, D. To find the reaction right at the support A, first I will take the right the reaction at B. So further you have to take moment about the support A. So what will happen? So there is an UDL of 10 kilonewton meter here, which is of anti-clockwise moment at A is minus 10 into 1 square by 2. So it is nothing but minus 5 kilonewton. Then after that 5 kilonewton meter. So due to this entire UDL, the span is 4 meter. Right, the moment about the support A is right, it is of 10 into 4 square by 2. Then there is a clockwise moment I call it as plus. Then due to the reaction RB, that is an anti-clockwise moment. Again I call it as minus, clockwise plus, anti-clockwise minus. So it is RB into 3 meter. Right, so I have included all the moments due to external UDL, overhanging portion, and this overhanging portion and this middle portion. So finally you will get right the reaction at B is equal to, okay. So if you are putting the summation, you will get 25 kilonewton, upward reaction 25 kilonewton. Then whatever the reaction at A, so total load is 10 into 5, 50 kilonewton. So this reaction is 25. So 50 minus 25 are getting an upward reaction of 25 kilonewton. Because this beam is loaded with a symmetrical load. Entire UDL of full span is right 10 into 5 meter. So 50 kilonewton, this is 25. This reaction is also 25. So this is about the reaction. Then what will be the shear force at various point? You can see the shear force at this point, that is left hand. So if you are taking section, here it is only UDL, so it is 0. The shear force at this point, that is at support A, to the left of support A, again it is minus 5 kilonewton. Downward, left downward is minus. Then to the right of the support A, reaction of 25, I am taking this. Now it is minus 5 plus 25. So I am getting a value of, so this load is, what is that, 10 kilonewton. So 10 into 1, 10, right, that is minus plus 25. You are getting right plus 25 kilonewton. So here it varies from 0 to 10 kilonewton negative value, then it increases to plus 15 kilonewton. Then the shear force to the left of B is nothing but this value, right? Already you have plus 15. This UDL is 10 into 3, 30, right? So it is a downward, left cross section downward is again minus, right? Plus 15 plus 30 is equal to minus 15. So what will happen? It having a plus 15, then it ranges from slowly it downs, and here it will get a value of, right, minus 15 kilonewton. Then what about this? Here it is UDL zero value shear force, but to the right of B load is 10 into 1, right down is positive. So 10 into 1, 10 kilonewton. So here is plus 10 kilonewton. Then it to the negative side of 15 kilonewton. So the shear force diagram we are drawing. So here it is minus 10 plus 15, somewhere between A and B it is 0, that is at the middle point of AB, that is 1.5 meter from the left support. Then here it is minus 15, again it increases to plus 10 kilonewton and makes to 0, makes to 0. So above the line here positive shear force of maximum 10 kilonewton, and at the middle point is 0, shear force changes sign. So at this point only you will get a maximum bending moment, because for a simply sorry any beam which have a symmetrical load, so the maximum bending moment will occur where the sign changes of shear force in between the beam. So it changes here from plus to negative. So this point, that is at a distance of 1.5 meter from either support, maximum bending moment will occur. So this is how we have to find the shear force diagram and shear force values at various points like C, A, and also at middle point here it is 0, here uh, B, and the right overhanging portion is D. So this is how we are finding the shear force diagram. In the next video lecture we can see about how to draw the bending moment diagram by finding the bending moment at various points, like at the left end value of overhanging beam, then at the support A, then at the middle of beam AB, then at the support B, then to the right hand overhanging portion which is of D. So this is how we have to find the bending moment diagram that we can see in the next lecture video. With this, now we have determined the reaction at the support end, then we have calculated the shear force at various points, and we have concluded the shear force diagram after getting the salient points shear force. Thank you very much for patient listening. வாழ்க வையகம், வாழ்க வளமுடன்.